There's a specific building I'm thinking of when I draw this, but we've all seen situations like this. There's a door I need to get to. It's a little bit high. There are steps to get up to it. And there's also a ramp, of course, for people that have wheelchairs or other disabilities. Obviously, if I have bad knees or something, which way do I want to go? Actually, I'm like, I don't want to go there at all if I don't have to. But if I have bad knees or if I have a wheelchair or something, I'm obviously going to take the ramp. So physically, what's going on here, and it's really related to which mountain would you rather climb? Which side of the mountain? This side or this side? It all depends on what type of person you are. If you like rock climbing, and you even like rock climbing to the point where you're going this way and hanging as you go, then you probably want this side. Because physically, what's going on in the real world? What's different on this side versus that side? We both get to the same point, don't we? In fact, here, I get to the same door if I go here or there. I get to the same place. I just do it here. I do it quicker versus here, right? You guys with me? Now, not quicker necessarily. It might take me longer to go, but I go up in much less time of going over, right? In fact, have you guys driven down Mission Hills? I used to live where you could see the bay. I had a few roommates, so we could actually afford a house where you could see the bay and stuff. It was really cool. And some of those streets down there, one of them in particular, the grade is so crazy. It must be about 10% or something. So have you guys ever driven somewhere where you saw careful trucks, check your brakes, 7% grade ahead, and they got the runaway truck ramps? You know what I'm talking about? The first time I ever saw one of those, I was like, oh shit. I was like looking behind me, runaway truck coming. What does that mean when you see like 10% grade? What the hell does that mean? What do we want the street to be? 0%. I want it to be flat. So thankfully, we got the physical idea of how quickly I go up or down versus how much I move left and right. And I've got the mathematical idea, which is the same. It's exactly the same idea. So what's different here? And I'm trying to get you guys to say the word. It's not the most common word. I think some of you guys know where I'm going with this, though. Slope. Thank you. So the slope here is less here than it is there. The slope here, which one's got less slope? Going up the stairs or going up the ramp? Which one is gentler slope? A nicer slope? A smaller slope? The ramp. The stairs, I get up there quicker. So I move over a lot less than I do here. So this has got a gentle slope. So we can handle it. So slope should mean something about, if flat is 0, and I start to have a little bit of a rise here, right? If flat is supposed to be 0 slope. And does that make sense? Are you guys cool with that? Flat has to be 0 slope. The minute I start picking up that one side, I'm getting some kind of a slope here, right? So it's got to be here. Is there any up and down for flat? No. So 0 up and down, 0 rise or fall. But there's always some kind of run in these cases that I'm giving here, right? There's some run going on. There's some left and right versus up and down. So here's the idea. To make the math match what we know in real life, we say that the slope mathematically is rise over run. So if I don't rise at all, there's 0 rise. What's my slope? What's 0 divided by? I don't care. If I don't rise at all, here I am going on the hopefully flat floor here. If I'm not rising at all, my slope is 0, right? 0 divided by whatever. How are we doing so far? So in that case, if I go 1, 2, 3 steps over, I've gone 3 steps, I've run 3 steps. How much did I rise in that same time?
0.
Not at all. So that's a 0 slope, exactly what we'd want flat ground to be. You with me? And let's see if this makes sense up here. So how much, if I start here I am with my bum knee from playing tennis. If I start there and I walk here, and And I'm very small. I'm a hobbit here for some reason, but going in this, the doorknob is level with my eye, but I'll get past it. How much have I gone up and how much have I gone over? Yeah, I've gone, in this case, I've gone over 9, up 3. So what slope is that? 3 over 9 is?
1/3.
Careful. 1/3. No, 3. 1/3. Versus, what would this slope be? How much have I gone? And once if I start here, and then I get it here, I've gone over 3, up 3. So the slope here would be 3 over 3 would be 1. So which one's bigger? The one the stairs. And then we said this one should be the gentle slope. It should be closer to flat. They're trying to flatten it out a little bit so it's easier to get up the damn thing, right? Do anybody hike at all? Anybody ever go hiking at all? Some of you guys. You know, they have these things called switchbacks. That makes it easier to get up. If you just went straight up the mountain, that would be like this. Holy crap. Unless you want that. Unless you want to have some handholds and some little cracks to put your feet into. Some of us want to go like this, woohoo, so that your slope is really flat then. You're just barely going up at all, and you're really going over a lot. Some of us are like, no, just get me up to the freaking thing. I can climb really fast. So I want to go up a lot more than I go over. You guys kind of with me how the math directly relates to what we know in real life? Cool. So how does this show up visually? How does this show up in a graph? Let's start there. We already saw this, but this is, I want to get a little bit more mathematical than my little tiny dude walking up to this door. So let's have a graph here. So if I started here and I went there. There's no little line segment, right? How much did I rise? How much did I run? Those are the two things I need to figure out my slope. 0 would mean flat. What would straight up and down be? We'll figure that out in a minute, but does anybody know what that would be? We'll figure that out in a minute. We'll get there. Let's just do this diagonal right now. Slope, which, who knows what symbol slope is given? What letter do we use for slope? Okay, well, not x. X is supposed to be whatever. Specifically, this will be m. To go from this point to that point, how much do I rise?
3.
1, 2, 3, 4. And how much do I run?
5.
Yeah, 1, 2, 3, 4, 5. Why am I way up there? 4 here. And then 1, 2, 3, 4, 5. Yeah. So I rose 4 and I ran 5. Are you guys with me? Sort of the same thing as saying, how do I get to your house from here? You go 4 blocks up and 5 blocks over. Same idea, right? So what is the slope here then? 4 over 5. I rose 4, I ran 5. So it's 4/5. So it's a relatively gentle slope. It's less than 1 slope, right? Should it really matter? And I didn't do this over here in this example. What if I went down this? Shouldn't it have the same slope? I don't care if I'm going up the stupid thing or coming down the thing. Shouldn't it have the same slope? If the slope changed and all of a sudden the ramp, something happened out there, some earthquake or something. So if I start here and go there, do I rise? To go from here to there? No, I fall. How much do I fall? Of course I fall 4. 1, 2, 3. I go down 4. I fall 4. So it's negative. And then how do I get back to there? 1, 2, 3, 4, 5. Back. You with me? Minus 5. So the slope is supposed to be the same, and we got all these stupid negatives coming out. But what is the slope now? Is still negative 4 over negative 5, which is the negatives cancel. The same. So it doesn't matter which point you start at, which point you end at. The slope is the same no matter which point you pick and which way you go. For a straight line, the slope must be the same. If the slope changed somewhere, what's going to happen to my line? If the slope's only changed, it's got a slope of 2. So it's going, and then suddenly it becomes 3, what's going to happen? My line is going to, what? It's not a straight line anymore, is it? It's now a curve, right? Okay, cool, maybe. So very last thing I want to leave you with, and then we're going to get out of here really nice and early. Next time we're going to work on some handouts and groups. Is I've got a visual way to do this. The visual way to do this is the rise over run. I need some algebraic way to do this. I don't want to have to plot points every time somebody gives me a couple points and says, what's the slope between these lines? What are the points are 7.91, comma, negative 12.38. I'm not going to graph that. I don't want to do it the visual way. Give me some mathematical way. So I can just plug it in a damn calculator or something. Let's spit it out at me, right? I need some mathematical way to do this. So let me see if you guys can handle this. Let's see what happens. Oh, shit. All right, here's where I start to lose people a little bit, but when I write something like this, it's not specific. It's just any points I want. Here's the first set of points. That's why it's x1, y1. This should sound vaguely familiar. Maybe not. Okay, we'll get there. And this is the second point. That's why I called it x2, y2. What is x1? I don't know any damn thing I want it to be. So we're about to develop a process that works no matter where the points are. That's what I want. I don't want to have to do, oh, it's in quadrant 1. I got to do this other thing. No, screw it. I want the same stupid thing every time. So what is this? How long is this? When I move up and down, which variable is involved? When I move up and down, which one changes?
Y.
Y does. And how much did Y change? And watch, I'll give you, look here. Why did we say this was 4? Let me see, this is the point negative 4, 0. And this is the point 1, 4. You guys with me? Right? So watch this. This was 4 because it was 0. And then when I moved up 4, it now became 4. You guys see that? So this changed by 4. How could I see that in the points? Y was 0 here. What is it there? 4. So 4 minus 0, it changed by 4. How much did the x's change? 5. How do I see that? 1 minus negative 4. So 1 plus 4 is 5. Because how do I tell the difference between two things? I take the subtraction. I subtract them, right? So here, how much did y change? Y2 minus y1. How much did x change? You should be able to tell me now, right? X2 minus x1. That's how much x changed. It was x1 and is now x2. So if I was 7 years old and I'm now 10, how much older am I? 10 minus 7, 3 years older. If I was x1 and I'm now x2, how much further along am I? x2 minus x1. So how do I find the slope? If somebody gives me 2 points, x1, y1, and x2, y2, the slope will be y2 minus y1 over x2 minus x1. Because again, it's rise over run, right? And when I rise, which letter changes? Or fall, for that matter? Y. Wasn't I making that point earlier? When you go up or down, it's the Y that changes. Watch the rhyme that happens. Y's rise. That kicks ass. The bottom I can't do shit with, sorry. Right, X's run, deal with it. But Y's rise, it's awesome. Rise is the Y's. Run is the other guys. There you go. Somebody do something. Run is the x2 minus x1. That's how much the x changes. So let me give you a couple examples. Let's do one together. Find the slope between 4, 2, and 3 and negative 5. Now you could plot them and count. That's going to take forever. Don't do that. Attack it directly. One thing I want you to realize, it really doesn't matter which one's y2, which one's y1, so forth. As long as you go the same way. That's why we have those up there. You can even label these if you want to. This is called this one x1, y1, and this one x2, y2. It does not matter. It doesn't matter. What's key is, if I do, so what's on the top now? y2 minus y1. What's y2? Negative 5 minus 2. So if I go this way on the y's, I better go this way in the x's also. If I change them, don't I get the wrong sign? I'm going to say it's a negative slope when really it's positive. And my boss is going to fire me because it's the slope of our profit. Johnson, you said you were losing money. Get out of here. So the direction of my movement is important. If I change one of them around, I'm going to have the wrong sign. So if it's negative 5 minus 2, it better be 3 minus 4 on the bottom. Negative 7 over 7. So my slope there is 7. So here you guys try 1. So find the slope between negative 1, 5, and 7, negative 4. Find that slope. Big sigh. I like that. If you want to. We're almost done, guys.
No problem.
Speak fast, so it can't be easy.
You simplify?
Could be, yeah. The answer you end up with is a fraction, so you should always reduce fractions. I don't care where they came from.
Okay.
Yeah, cool. So what do you guys have on the top?
Negative 4 minus 5.
All right, so negative 4 minus 5 over
7 plus 1.
7 minus negative 1, good, which is plus. Cool. So you get negative 9 over 8. And so this one you can't do anything with. So see what you did though. You did the 7 minus 1, you forgot.
Yeah.
Yeah, be careful. The equation has a minus sign in it. The number could itself be negative, which in that case it becomes plus, right? Be really careful about those negatives in this equation. Who did it backwards? Anybody do it the other way? What if you did 5 minus negative 4? Over negative 1 minus 7. That's still 9 over negative 8. That's still negative 9/8, right? So as long as you go the same way on the top and the bottom, you're golden, you're fine. Okay. I think that's plenty. We did 3 sections today. That's damn good. So next time we'll have, we'll start off with some group work, and then we'll do one more section on Monday. Cool. Anybody else not get their test back?